Now we take forward. This is the nothing but electric dipole. Electric dipole. Electric dipole. It is said to be electric dipole. Now what is electric dipole? Suppose this point is Q1, gives the charge Q1, and this gives charge Q2. The distance between them is R, we can represent here. This charge and this charge separated as finite distance or little distance, we can say. System of equal and opposite charge separated by small distance. It is a system. The two charges equal and opposite charge. Q1, Q2. These are said to be equal but opposite, separated by a small fixed distance, and this distance is said to be a fixed distance. This distance is said to be a fixed distance. These are two charges equal but opposite, and they are separated at a finite distance or fixed distance, and that system is said to be electric dipole moment. We know that electric dipole moment, we have to mention for the representation of electric dipole moment, electric dipole is represented as P, and P is nothing but Q times 2 into L, or P equals Q times 2L, or P equals to 2QL, where Q is the magnitude of one of the charge and 2L with the length or fixed distance between these two charges. So we have magnetic dipole that is equal to 2QL. This is said to be, this is the dipole, and this is said to be, P is for electric dipole moment. It is electric dipole. The system, two equal and opposite charges separated at a fixed distance, and this is said to be electric dipole. Now after that, electric dipole moment. Electric dipole moment is nothing but the product of magnitude of one of the charge and the fixed distance, or the distance between these two charges, and the distance between these two charges is taken as 2L or 2 into L. So we have here electric dipole moment P equals to 2QL. This is the electric dipole moment. The direction of P is from negative charge to positive charge. That is P, and P is nothing but electric dipole moment. For the representation of the direction, we have mentioned that the direction of vector P, if we draw vector, it is equal to Q times 2L. So we can take it is as the direction of P from negative charge to positive charge. Here it is said to be P equals to Q times T, Q times 2LT. Here P equals to Q 2L. The direction of P, here we mentioned that P is the direction. Simply you can say that P equals to Q to K. Okay. P equals to QL. Unit, the nothing. You know that what would be the unit? Kilometer. It is the unit for coulomb debye in this system. The dimensions are nothing but m raised to 0, m raised to 1, m raised to 1, and m raised to 1. These are the dimensions for electric dipole moment. This is the electric dipole. I think you got it. Electric dipole. It is the system of charges or two charges equal and opposite. These are separated at a finite distance or fixed distance, and that is said to be electric dipole. And electric dipole moment, it is nothing but the product of the magnitude of the charge and the distance between the two charge or fixed distance, and this fixed distance of the electric dipole is taken as 2L. Suppose from this, it is said to be the center of the distance. From here to here it is taken as 1L, and from here to here it is taken as other L, L plus L, 2L. This is taken as 2L. This is said to be P equals to 2QL. The electric field produced by a dipole is known as dipole field. The electric field which is produced by the dipole, that is said to be dipole field. The dipole field has a cylindrical symmetry, and that dipole field has a cylindrical symmetry. We can study later on. Now here it is all about the electric dipole and electric dipole moment, right? Now we have to calculate. Electric field intensity due to an electric dipole moment on its axial line. Now question arises, what exactly the axial line? Suppose here we take as one of the charge, and here we take as other charge, both having equal magnitude but opposite direction, and the line which is passing through and Q1, Q2. This is said to be the axial position or axial axis of that system. So a line passing through the positive and negative charge of the electric dipole is called axial line of the electric dipole. This line is called as axial line of the electric dipole. This is called as axial line of the electric dipole. What I said, the line which is passing through the dipole. Dipole means the two charges separated fixed or finite distance. This line is passing through that dipole, and this is said to be axial line of the electric dipole. Consider an electric dipole consisting of 2-point charges, that is minus Q and plus Q. Here we have minus Q. Instead of Q we take it as minus Q, and here instead of 2 we take it as Q plus Q. These two charges are said to be spaced at a fixed distance. It is a dipole, and from that dipole a line is passing, and that is called axial line of the electric dipole. Now for that we have to calculate the equation, end of the position. We have to calculate the equation for that. For point E1 is the electric intensity at point P. Suppose here is point P, and we have to calculate the electric field intensity at particular point, and that P has a point minus Q. The P has a charge minus Q. So according to the definition of electric field intensity, vector E1 equals 1 upon 4 pi epsilon 0 k into Q1 upon R plus L bracket square into minus I cap. It gives the unit vector along only x-axis, because we are just talking about the linear direction on the x-axis, so we have taken as a negative direction. So this is said to be our equation 1, or you can simply say that in magnitude form, E1 equals to 1 upon 4 pi epsilon 0 k into Q upon R plus L square. It is for point P. Now for point Q, on which the charge plus Q is placed, for point Q, E2, vector E2, it is equal to 1 upon 4 pi epsilon 0 k into Q divided by R minus L bracket square into I cap. or E2 equals 1 upon 4 pi epsilon 0 into Q upon R minus L square. We have these two equations. If we consider vector form or magnitude form, there is also vector form and magnitude form. Now, the resultant intensity is nothing but E equals E2 minus E1. E equals to E2 minus E1. So from this we know that the value of E2 is nothing but E equals 1 upon 4 pi epsilon 0 k into Q divided by R minus L square into I cap minus 1 upon 4 pi epsilon 0 k into Q upon R plus L bracket square into minus I cap. Now some terms are constant here, common. E equals 1 upon 4 pi epsilon 0 k into Q times 1 divided by R minus L square minus 1 divided by R plus L square into I cap. So we have E equals to Q divided by 4 pi epsilon 0 k. Here R plus L bracket square minus of R minus L bracket square upon R square minus L square into bracket square. After solving this, E equals Q divided by 4 pi epsilon 0 k. Epsilon 0 k. Here R square plus 2RL, expand this, RL plus L square R square minus plus 2RL minus L square upon R square minus L square bracket square. Here this plus R and this minus R square will cancel. Here plus L square and this minus L square gets cancelled. We have E equals Q divided by 4 pi epsilon 0 k into 4 RL divided by R square minus L square bracket square into I cap here. So 2 into 4 equals 1 upon 4 pi epsilon 0 k into this 2 transmit 2 into 2q L into R upon R square minus L square bracket square into I cap. Here 2ql is nothing but P. So we have this equation. P equals 1 upon 4 pi epsilon 0 k into 2pr. Now look here, is also in the form. This R here, the L is very smaller than R, so it can be neglected, so it becomes 0. So it becomes R square into square, that is r raised to 4. Here this r cancel with one of this r, and it will give this vector E equals 1 upon 4 pi epsilon 0 k into 2p divided by r cube. This is the required expression for getting the electric field intensity at the axial point. And we know that what is the axial point is. Axial point is the line which is passing through the dipole or electric dipole. This equation. Similarly, we can obtain other kind of equation using this type of equation. This is the particular. If we try it in vacuum, for vacuum, E equals to 1 upon 4 pi. For vacuum it becomes only for epsilon 0 into 2p upon r cube. Here I cap. Is it vector form? It is in magnetic form. This is the required equation for electric field intensity for the axial point. Now we have another equations here, that is electric field intensity due to an electric dipole at a point on the equatorial line, that is broadside on the position. Equatorial line means the line which is passing through exactly center of the axis or the center of the axis on the axial point, and that is simply equatorial line. We can solve it later on. The final equation for that is E equal to nothing but 4 pi epsilon 0 k. This is for, I think, we hope you understand how we obtain that value for electric intensity for the axial point. Now, just look forward. We just mention the equations. This is equation we have seen here. The next equation, electric field intensity due to an electric dipole at a point on the equatorial line. For that point which is at a point on equatorial line. So the final equation for that is nothing but E equals to 1 upon 4 pi epsilon 0 k into p upon r cube. We will get the proof later on for that point. We can solve it as well. And for another equation is for the electric field intensity at a general point due to short dipole, and that is nothing but the equation E equals to, this is the second, the third one. The solution of these three equations we will solve in the next lecture. So we have here